anyone in the scientific community who firmly believes there's absolutely no evidence whatsoever for current microbial life on Mars. How do you respond to that?
So if someone tells me there is no evidence for life on Mars, I would take that, extant life on Mars, I would take that as an introduction to a conversation.
Dr. Stephen Benner is an award-winning biochemist who has published hundreds of research papers in the fields of chemistry and synthetic biology. He earned his master's degree in molecular biophysics and biochemistry from Yale University and a Ph.D. in chemistry from Harvard. Dr. Benner was also a professor at Harvard University, ETH Zurich, and most recently, the University of Florida. He's founded multiple companies, including the Westheimer Institute of Science and Technology, Aerogen Biosciences, and Firebird Biomolecular Sciences. Throughout his career, he's initiated synthetic biology as a field, invented dynamic combinatorial chemistry, established paleomolecular biology, and helped found evolutionary bioinformatics. He now works at the Foundation for Applied Molecular Evolution in Alachua, Florida.
It reminds me of what you quoted in one of your talks, the Jeff Goldblum.
Yes, life finds a way.
Right.
Exactly.
Right.
Well, look, it's a good question. I mean, we have had on Earth a series of catastrophes that have come close to extinguishing life as far as we know. Maybe you've come across the Great Permian Extinction about 270 million years ago. Something happened, we're not really quite sure, but 90% of the species are disappearing. And for the first time in several hundred million years, calcium carbonate, which is a resource in the ocean used to make shells, is now precipitating without making shells. So you've basically wiped out enough ocean life that it no longer can use that scarce resource, but life recovered. And so the question is going to be on Mars. There's no question that Mars, 4 billion years ago looked very much like Earth. It had oceans, it had atmosphere, it could have very easily sustained the origins of life, but it cooled and dried, and so now you got to ask the Jeff Goldblum question: did life find a way to survive the planetary change and survive until the modern day? Now, it's a good question. I mean, we know on Earth, every place you look, there's a little bit of water, a little bit of energy, you got life. And if you don't have water or energy, you'll find dormant life that will come to life or back to life when you give it water and energy. And so, we know that on Earth, life has found a way. And this is not Jurassic Park, that's fiction, right? This is fact, right? But life is in Antarctica, it's in the Arctic regions, it's in the dry deserts in Chile. Now, you got to decide whether you are enough Goldblum to think that life on Mars, which certainly was there at some point, if only by exchange, intercourse between Earth and Mars, whether it would have survived as the planet changed.
Well, you got to my last question, which was, we'll start at the end here. Was Mars like Earth?
Yeah. Well, and how do you know? Well, the answer is you can go look at the surface of Mars, and there's a couple of things that are very similar. One is, it looks a lot like Iceland in terms of the rocks. These are volcanic rocks, a lot of them are basalt. You can look at the pictures of Mars and you can also see channels that are cut by water that would look very much like channels that you would see in the Mojave Desert. The question is, how long ago was there flowing water on Mars that was cut by channels? Now, we have orbiters going around Mars and they take pictures, and every now and then they come back and take a picture of the same spot. And you will see from time to time evidence that there has been water flowing on the surface of Mars, even in the modern day. You can look at places where cliffs have collapsed to reveal ice that is beneath the surface, 10 feet, maybe 20 feet, maybe 100 meters, this type of thing. So you can see there is water at mid-latitudes. It's just frozen, and you can see that. And so, but if you go look at the terrain, it's not going to look different on Mars. We can see shorelines on Mars. Of course, now that there are rovers on Mars, we see salt flats, precipitated salt like you will see in Bonneville, salt flats in the American West. So there's no question that there was water on the surface of Mars. And in lakes and rivers and things like that, there were much smaller oceans. There's a much smaller inventory of water on Mars than there is on Earth, but still there was an atmosphere, and there was a lot of things where if life emerged on Earth because of a combination of chemistry and geology, it likely also emerged on Mars. And the other thing you have is, we get rocks back and forth from Earth to Mars all the time. You can go over to eBay and buy specimens of Mars that have landed in Northwest Africa and have been picked up by camel herders and then sold into the Western market. Some of the specimens on eBay actually are real, but I've got 5.5 grams of Mars in my office, and we have a very good idea from those limited samples what Mars looks like on the surface, and it doesn't look much different from what we have on Earth.
Sure. So if you're saying that, well, Mars had rivers, lakes, and perhaps even small oceans.
Yes.
That must mean it also had a thicker atmosphere.
Yes.
So when you have a thicker atmosphere and you have liquid water all over the place, one would presume, well, the chances that we might find not just microbial life, but perhaps even advanced life there doesn't sound too far-fetched.
It doesn't sound far-fetched. I mean, keep in mind there's also another process which I mentioned. If I get rocks from Mars in my office coming by impact on Mars, ejecting rocks, having them travel through the solar system and then land in Antarctica or Sahara Desert, someplace where they would be recognized and picked up. There's also rocks going in the other direction. Not quite so many. Ejection from the Earth is much more difficult than this. You're going the wrong direction away from the sun in terms of gravity. But yeah, there's going to be exchange back and forth between these planets in the 4 billion year time frame when there is habitability, undisputed habitability potentials on both planets. So both planets are going to be infected. Now, whether the life originated independently of the two and then was exchanged and maybe one life form took over for the other, it's hard to say. But yes, now the next question is advanced life form, right? Which of course now has to talk about what you think is advanced. Now,
anything beyond single cell.
Yes, that's right. So it's a good question. We don't know, right? And of course, keep in mind, there's not a lot of multicellular life on Earth until about 500, 600, 700 million years ago, maybe 10% the life of the planet. But you got to keep in mind that there are microbes. We tend to see a microbe as living by itself, right? But in fact, microbes make friends with other microbes. They form films and mats and stromatolites. And so there's a fine line separating a lot of microbes getting together and cooperatively managing an ecosystem versus, a multicellular organism. And the difference fundamentally is whether the unit of reproduction is each cell or, in your case, only a specialized cell of you as a multicellular organism. Now, it's a good question. We don't have multicellular life by some definition on Earth until after Mars has lost its atmosphere and lost most of its water. So the next time we have exchange between the two planets that brings multicellular life in that direction, it will be because of NASA or the Chinese National Space Agency or the European Space Agency.
So let's talk about the search for current life on Mars.
Yes.
Okay, let's rewind the clock just a little bit.
Yeah.
Go back to 1976.
Yep.
NASA sends this really ambitious mission to Mars.
In duplicate.
Yes. Viking 1, Viking 2,
Yeah.
both have an orbiter, both have a lander. This is an incredible feat of engineering.
It's the most expensive experiment in science that was run at that time, yes.
And it seems, by comparing it to what we're sending today, I mean, it just seems like this Herculean effort.
Yes. Well, considering the fact that the computers today are so much better than they were in 1976.
So NASA sends these Viking landers down to the surface of Mars. Aboard each one of these landers are a few different life detection experiments. Okay, and after running these tests, they basically conclude that there's no life on Mars.
Right.
Now, you have a blog post titled, "Why Does the NASA Culture Still Get Viking 1976 Wrong?"
Right.
Referring to their conclusions about the life test experiments. And quoting from one of your presentations online, I think to the Mars Society, you basically conclude that, well, that the culture of NASA is stronger than logic.
Yes. Well, it's the culture. I mean, the problem with science is it's done by scientists, right? So we don't, as scientists, as humans, necessarily stand objectively away from what we want to believe, what we've been taught to believe, and let logic influence. And this is not just NASA, right? This is, in fact, all of science, and in fact, it's all of human beings. So you have a very amusing problem, right? You go, and there are two ways of looking at this, right? You can actually look at the experiments that were done by Viking in the order that the experiments were done as the data appeared and how they influenced humans. With all of our human frailties, you have them too, right? We can watch how they proceeded through those weeks, and those are all recorded in a mission log, which you can go find on the bottom shelf of the library, the Lunar Planetary Institute in Texas, if you want to. But there are other places. Right, what you discover is that the first experiments that are being done are putting radioactive food onto the surface of Mars. There's water with it. And then you're looking at the evolution of radioactive carbon dioxide from the food. Now, if I take you and I put radioactive food into you and in water, you will exhale radioactive carbon dioxide. This was the experiment that Patricia Stratt and Gil Levin. Gil just passed away a few years ago at age 97 or 98, something like that. And so that was the experiment that they had designed, and that was a positive life detection experiment based on the frame of the experiment, how it was designed. Now, a couple of questions were not asked at the time, which you might ask yourself, and I can give you sort of a Socratic approach here. So what should you ask if I tell you that food is being oxidized to carbon dioxide? You might ask, what's doing the oxidation? Well, they didn't ask that question. Interesting. Fair enough. Second experiment came online, which was done by, well, there were two other experiments which were in some sense photosynthesis related. Norm Horowitz did an experiment where he shined light on the surface, he put radioactive carbon dioxide in the atmosphere, and he looked for the fixation of the radioactive carbon dioxide that's a technical term, which means that he looked for radioactive carbon dioxide ending up in plant material, which is what happens if you go out to the grass. You put radioactive carbon dioxide above the plant, you shine a little sunlight on it, it will fix the carbon dioxide into plant, and then of course they heat the plant and they get the radioactive material out. They saw the fixation of carbon dioxide. They saw what they thought would be photosynthesis. Now, it's a kind of a problem. It turns out they were sometimes putting light on it, sometimes they were not putting light on it. In principle, these plants can fix carbon dioxide without light. There was a third experiment which was done where they were basically looking for gas exchange, so they were looking, as it were, for the evolution of oxygen, which is also what happens in photosynthesis. Right? If I sprinkle water on my plants, and I can see gas released from the plants as oxygen comes off as photosynthesis. They saw that also.
So we see these positive indicators.
Yes.
Back in 1976, NASA does.
Yes.
Okay.
What happens?
We'll get more into the specifics here and the developments here, but I just want you to comment. There is this hesitation, perhaps even reluctance, perhaps even just downright ignorance or just refusal to re-examine just what it is that Viking found in 1976 among NASA and the scientific community at large. And you're speaking to the culture here. You're speaking to these qualities about us humans that once we're set on an opinion, we're set on a conclusion, whatever it is, it's hard to change that. We're not using logic. It's just there's this culture we're wrapped up in.
Well, what happened was another experiment finally came online, which was a mass spectrometry experiment. For your audience, what they did was they scooped some sample off of the surface of Mars. They put it in a cup, they heated it up to high temperature, and they looked for the evolution of organic molecules coming off of that experiment. They didn't see any, and so that they concluded that there were no organic molecules in that sample. Now, you can be Aristotelian if you want. You want to be logical. We should be logical. All life requires carbon, reduced carbon. There is no reduced carbon in the soil on Mars. therefore there is no life in the soil on Mars. And that's a syllogism that Aristotle would recognize as such. And that is the result that came later in the actual sequence of events. But if you look at Norm Horowitz and other scientists who retrospectively look back at this experiment, that's the first thing they mention, that there's no organic molecules in the regolith of Mars, the soil of Mars, right. And therefore there's no life there, which means that every other experiment where we think we saw the evidence of life has to find a non-life explanation.
Right. So we'll get into.
And so we go looking for them, right?
So, okay. So the other, I want to quote you from.
Okay.
Take another one of your quotes. Okay. In one of your blog posts, you say, "The Viking 1976 life detection results are compatible with a model for autotrophic microbes that have evolved a lifestyle adapted to Martian environments, where water and organic carbon are scarce." You continue by saying that the Mars community has not, it seems, considered this model. For the most part, the community seems unaware that this model exists, even today.
Yeah.
The community seems to think that the Viking mission proved the absence of life at the 2 Viking landing sites. And, you know, I'll even talk to astrobiologists directly today who, you know, they think, well, I've seen no evidence for life thus far on Mars. And I'm like you. I question whether or not they've re-examined these results in light of finding organics and even just further discovery of evidence of life on Mars. So,
well, work with me here.
Yeah.
So the minute you think there are no organics on Mars, and let's just say that the organic theory of life is stronger than the metabolism theory of life. So Gil Levin's experiment, Norm Horowitz's experiments, these are looking for metabolism, chemical reactions. Mm-hmm. But of course, all sorts of things that are not life do chemical reactions. Your car does chemical reactions, right? So the absence of organic molecules trumps, right? If that result says no life, it's going to trump all the experiments that you do that say by evidence from metabolism that there is life. And so that's what they did. I mean, in fact, you look at the mission logs within, weeks, not months, of the discovery of the absence of organics on the surface of Mars at those 2 sites. They have explanations that will explain all those other 3 results without invoking life. Mm-hmm. Now, there's a problem. Those explanations turn out to be problematic, partly because there's another twist here, and it's kind of fun. Organics come to Mars all the time. They fall in by meteorites. We have them coming to Earth all the time. So there was a huge inventory, there should have been a huge inventory of organics falling to Mars. And in fact, before the Viking mission flew, you can see the discussion that maybe we should not send the gas chromatography mass spectrometry instrument to Mars, because all it's going to do is discover the meteoritic organics that we know are there and they're not biologic. So there was a big discussion as to whether to send this GC mass spec there at all. But when they sent it there and it found no organics, there was an added paradox, an added anomaly. That is, I expected to find organics, not bioorganics, but the stuff that was falling into Mars all the time, and it wasn't found. So the question is, where did it go? Well, now they said, well, wait a minute, maybe it was oxidized. Well, by what? No one asked that question either, except they started to ask that question because they had to. How do you burn away all these organics that should be there that the GC mass spec was not able to find? Mm-hmm. And so the argument became, well, there must be an oxidant, an inorganic, a non-biological oxidant in the soil, which is toasting all the organics that fall in from meteorites, but it's got to be so active. It's not a mild oxidant, it's a very active, because it has to also oxidize the food that Gil Levin puts on the surface. In minutes, it has to be a really strong oxidant there on the surface. And so all of a sudden, the culture goes to the statement that the surface of Mars contains not only no organics, but to get rid of the organics that we know come there every day, it's got to contain an oxidant, and not just any oxidant, a strong oxidant, and not any strong oxidant, an oxidant that is so strong that it explains how Gil Levin's food gets converted to carbon dioxide when you feed it to the surface.
So let me continue here. You say, quoting from your other blog post here. In 2021, NASA assembled a committee to define community standards to be used to judge claims by those who thought that they may have detected alien life. And the report itself is quoted as saying, since Viking, it's been recognized that there are numerous possible non-biological explanations for the labeled release results. The results of the Viking gas exchange experiment, which demonstrated that the regolith was chemically active, and the search for organics using the Viking gas chromatograph mass spectrometer further support a non-biological interpretation of the labeled release experiments. Additionally, detections of oxychlorine compounds on Mars, perchlorate and chlorate, during the Phoenix and Mars Science Laboratory missions indicate the occurrence of processes that can explain both the Viking labeled release and gas chromatograph mass spectrometer results. And your response, quote, every word in this statement is wrong, including and the.
That's right.
So you adapted a famous quote.
That's right. We took this wrong thing. Yes. So here's you jumped a number of years and you've missed a little bit in between. So in between, you've had rovers wandering around Mars and they're looking for organics as well. And of course, they find organics all over the place on the surface of Mars. Okay. So this is 2003. Steve Squires has a rover. We have rovers going all the way up until today, and they're finding organics all over the place. Furthermore, in 1999, my only real contribution to this whole discussion was we published a paper which showed that the GC mass spec instrument, the instrument that allegedly found no organics on Mars, could not have found the organics that are most likely to be there, even if it was sitting on a pile of them. So poor Gil Levin, he sees Benner writing a statement showing that the mass spec would not have detected organics even if they were there. He wants to know, wait a minute, the logic was there were no organics there, therefore my experiment, Gil Levin's experiment that is, had a non-biological explanation, but now Benner has shown that there are organics there. In fact, forget Benner, all these rovers have shown there are organics there. Therefore, we should go back and revisit the logic that tossed my result being Gil Levin's, and conclude that, wait a minute, we're back to the status quo ante. We're supposed to say that maybe those are life detection signs, as well as the Horowitz experiments and the oxygen release experiments. But that did not happen. Furthermore, they did discover perchlorate at Mars, and we know that perchlorate does oxidize things. So Gil Levin's food, if I take perchlorate and put it onto the Gil's food, or put Gil Levin's food onto perchlorate and heat it up to 400, 500 degrees centigrade, that's fireworks, by the way. That's in fact how they make fireworks. They put perchlorate in with organic materials and it burns it. It sets it on fire. It also makes something called chloromethane, which is a twist to this story, which becomes interesting in 30 seconds. But before we get to the 30-second remark, right, we actually know that the reason why they didn't see organics in the experiment that was alleged to show that there were no organics was because they set them on fire because of the perchlorate in the soil. So Chris McKay, NASA Ames, good friend, did some studies where he took organics and perchlorate and mixed them and heated them on Earth and sees the emergence of carbon dioxide, fireworks, and a little bit of chloromethane. And so he basically has shown that all of the experiments that allegedly were done in 1976 to rule out organics in the soil were in fact because they did experiments in a way that could not detect them, or at least what they detected was actually quite consistent with organics in the soil. And that's also consistent with rovers that have padded around all the time. And, you know, and our 1999 paper said, well, there's going to be something called benzoic acids in this, or never mind what these are. The only thing that's important to know in 2021, Milan and her team, she's the first author on this paper, found benzoic acids in the Bagnol dunes on Mars. So I have my 15 minutes of fame saying I predicted these molecules will be found on the surface of Mars, organic molecules, and they were in fact found. So you're in a situation right now where by the time you get to 2021, and you have NASA convening a committee to decide when we should allow people to publish the claim then we have detected life in an alien environment, right? We have the people in 2021 not apparently understanding that the experiments in 1976 that were used to explain provide non-biological explanations for the results for the life detection experiments had for 20 or 30 years been set aside, well understood by chemistry that was done by Chris McKay and others here on Earth. And the fact remains that there are organics on the surface of Mars, but because we have taught for so long that there are no organics on the surface of Mars, even though the rovers find organics on the surface of Mars.
This is old news by now, because Curiosity detected them a decade ago.
Yes, that's absolutely. This is old news from 2010.
Yet we still have scientists today who are just beholden to this narrative.
Yeah, but it's a fascinating, you'll find, or at least I certainly find in my thinking, I won't impeach your thinking quite yet, but you'll find even in my thinking over the years, I will hold on to ideas that I've had and not change them, not because I am terribly obstinate, but because I don't even think about changing them.
Well, okay, we're human.
Yes.
Okay, humans are flawed.
Yes.
However,
that's right.
I find that the scientists that I'm speaking to, they're not familiar with the history.
Is that right?
They don't know the particulars of Viking. They just say, oh, well, the results are inconclusive because that's what NASA said. The results are inconclusive all the way to, well, there is no evidence. Yeah. And I'm thinking, okay, well, I'm just an average Joe here. I'm just a filmmaker. I'm a storyteller. But even I am familiar with these particulars here, and I find them quite compelling, especially in the wake of finding these organics, which is now yesterday's news. As you said, they're all over the place. And when we speak about this culture, Gil Levin had to go up, Barry DiGregorio was telling me, relaying this story to me, where Gil Levin goes up many years later after Viking and doubles down on his conclusion that, this is evidence for the life test finding life, and not a chemical reaction, okay? And, it generates such a heated response.
Yes.
Now,
fascinating, isn't it?
Well, you're on this, what's it like to have this differing opinion, differing perspective than the rest of the scientific community?
Well, I mean,
who else agrees with you?
Well, Chris McKay will talk. I mean, there are lots of people who understand this, but you're right. Keep in mind, what makes you think you know anything like what the Amtrak schedule is today? Well, the answer is because you have been told it on a web page. Now, you probably haven't studied the Amtrak schedule and probably don't know what the Amtrak schedule is, and you don't have time in your life to understand all of the details that you think you knew to know that the Amtrak time schedule could even exist. Right? You have to know something about the stability of iron in the railroad track so that it won't evaporate in this heat, and therefore you can still have an Amtrak track. I mean, so yes, if you go back and look at any science, you will discover that people do not know the primary data that leads them to believe what they think to believe. So you believe that water is H2O. Now, I'm not going to give you a Ph.D. examination because you're not standing for a Ph.D. in chemistry, but I will ask graduate students who are standing for a Ph.D. in chemistry and ask them, what are the primary data that lets you believe that water is H2O? And they will not know them. Okay? Now, is water not H2O? I don't know. I mean, if someone walks up to you and says that water is not H2O, it's H3O, what are you supposed to say? Now, what you say is, you're crazy, go away. You're an uneducated lout if you think that water is H3O plus. Now, the correct thing, that's fine. But remember, if you said that over the last 100 years, you would have missed every major advance in science, because every major advance in science starts with an explanation or a statement, a proposition, if you will, that something that you think is true is not. This, of course, is the Richard Feynman line, that science begins with a distrust of experts, right? If you believe in experts, you don't do science. Your life is settled. You just go forward. But you cannot dismiss data that contradict your expectations, or if you do, You miss everything that's interesting. Now, don't get me wrong. If I accept everything that contradicts my expectations, I spend my entire life chasing down instruments that are broken and experiments that failed because the substance was impure, right? Almost all the things that you do in experimental science create problems because the damn equipment doesn't work, right? Or the light bulb has burned out, or right? And so one ends up having to be in science disregarding anomalous results just to make your life simple enough that you can make it to dinner, right? On the other hand, every now and then one of these results comes along that is not the product of a machine being broken or a light bulb being burned out, but actually is reflecting the fact that your theory is wrong. And of course, it takes enormous discipline, which we try to train in students, right? To actually, well, in the first place, it takes an intuition to distinguish between anomalies that are meaningful and anomalies that are just a broken instrument. But we also try to train into students the discipline to challenge the thoughts that they think, challenge propositions that they think are true, especially when they're propositions that they want to believe to be true. That's a discipline in which we don't train very strongly, even in scientists, but it's something that's very...
But this is... Okay, it seems like that based on this presumption that
Yes.
Mars has no evidence for life.
Yes.
Okay, when we find, and I'll credit Barry DiGregorio for cluing me in on the research that's being done on what appears to be rock varnish
Yes,
on Mars.
desert varnish. Yeah.
We have photographic evidence of it. We can't go up there and scrape it up, but we do see it in pictures, and hey, it looks like it. So let's analyze it as if it were that. But they're under the presumption that because there's no evidence for life on Mars, that they have to find a chemical explanation for this.
Yeah,
And
I would not mind having a chemical explanation for desert varnish here on Earth, right? We don't quite know it. I mean, we can find desert varnish in Arizona, and I don't know what that is myself, even though I've looked into it, right? It's an interesting question as whether it's a biological or non-biological
But they're
process.
twisting themselves in all sorts of directions, trying to find a chemical explanation for this.
Right.
Okay, because they are so beholden to this idea that there is no evidence for life on Mars.
Well, I might try to find the correct way to do this when I'm teaching students, which is a different statement of what I do in my daily life, right? But you're supposed to say a phenomenon, call it desert varnish. I'm supposed to set up two competing models, one of which it is life and the other that it's not life, and then try to see how I can do experiments to advance either one of them. It turns out that if I really want to believe that it's not life, we try to train our students in the discipline where they discredit data that confirms what they want to believe, and they credit more data that contradicts what they want to believe. It's sort of like high school debating, right? We force you after you argue in favor of war to argue against war, and all right, so that you get... And this is very, Orson Scott Card, right? You have to live in the shoes of the opposing paradigm. And then if you do, you will, only then will you, if you have to believe that there is life if you start out believing there is no life, or you have to believe that there is no life if you started out believing that there is life. And only after, if you live in the shoes of your opponent, grow to know it so well that you love it, right? Then you are able to actually understand what, in fact, the discussion is. Before that, it's not that you don't credit or discredit an idea, you don't even know what that idea means until you actually live in it. And so but we try to train students to do that. But you're right. I mean, in principle, I'm supposed to look at desert varnish and try to come up with two competing hypotheses, and then try to collect data this way and that way to understand how in my desires influence my evaluation of the data. And then at some point try to make progress. With Mars, of course, desert varnish all of Mars exploration has a time scale that is very, very long on the human lifetime time scale. So it's better perhaps to go out and study desert varnish here on Earth. But yeah, so don't, what you're supposed to do is go do both. And of course, people don't do that. And part of it has to do with the fact that they don't have the time.
But this seems like culture to me.
Well, it is.
Because even if you go back to curiosity not only found organics, they found something very specific. Okay.
Yes, yes.
And Professor Hoover clued me in on this. He doesn't understand why NASA doesn't make a bigger deal about the fact that they found dimethyl sulfide.
Yes.
Now, as I understand it, here on Earth,
Yeah.
the only way we can figure out how to make dimethyl sulfide is through active microbial activity.
Yep.
There is no abiotic explanation for this.
I mean, I can, yeah, that's
Maybe some smart people can cook something up in a lab, but still,
well, yeah, no,
that requires a human.
There you go. That's basically what I was going to say.
There's no laboratory on Mars cooking this stuff up.
I don't think so. But sure, look, I mean, I hate to go back to the phrase, who's got the time? Okay, you're right.
But this is one of the biggest questions ever.
Well,
is there life outside of Earth?
So you say, let's go start from scratch. You said that most people you've talked to in the astrobiology community do not know the details of the Viking 1976 experiments. And that's true. I myself have to go back and study maybe 20 papers from Norm Horowitz to know exactly what they did, because I'm trying to construct a non-life scenario and a yes-life scenario.
And by the way, your posts do an excellent job of doing this.
Oh, thank you.
I was like, man, this guy really knows his stuff. You've done your homework.
That's right.
And that's fantastic.
Well, that's, of course, part of the training, right? Because I do have the time.
You're a serious scientist. And
okay.
You outlined it in such an explicit manner that I'm like, this is what everyone else should be doing. It's following your lead, going back, taking a look at the details. And I'm not necessarily saying, okay, maybe you don't know the entire detailed history of the mission logs, et cetera, et cetera. But I can list for you 5 examples of evidence for life on Mars. We just talked about desert varnish, okay? It's not proof.
Yeah, of course not.
It's evidence. There's a difference between evidence and proof.
Quite.
Okay, I once asked this to an astrobiologist, would you agree that there's a difference in meaning between the words evidence and proof? And he just stalled. He wasn't sure how to answer. And I'm like, how can we not answer this most fundamental question? So we talked about that. We talked about dimethyl sulfide. We talked about label to release experiment. Okay, we have the methane plumes. We have the oxygen. These things coming in seasonally, ebbing and flowing. Yes. All right. Not to mention that there's water all over the place, and we'll get to that in a second. But when we have this assumption based on, this is where you have to blame the culture. I do appreciate you're the only one I found who's speaking about the culture out in the open like this. When you have this conclusion based on the gas chromatograph mass spectrometer, it said new organics in 1976. They found them later. They didn't seem to do a big, sorry, we've led everyone down the wrong path for the past 30 years. Let's make a very public and visible effort to go back and re-examine these results, like you have.
Yeah, it's right. I'm not going to deny the compliment. It's very much appreciated. And there are people, Chris McKay, as I've already mentioned some of his work, and he's aware of this. And it's an interesting question, like Columbus, is the world round? Well, okay, Columbus went to the Portuguese who, knew how big the world was. They knew it was around, and they knew that Columbus had underestimated the size of the earth, and so he had no chance of going to India by selling glass, and besides, they were going around Africa and getting to India. So there is this view that those who are in the business of knowing know what went on in the Viking experiments, but there are very few.
But even since then, we've found these other things, including, now, let me ask you this, spectroscopy.
Okay.
We use spectroscopy.
Big word, yeah.
Yeah, you shine a laser or something, and then it reflects back a certain frequency, and we can kind of tell what it is, right?
It tells you something about the structure. Yes.
I read a research paper where we're using spectroscopy out in the desert as an analog for Mars.
Yes.
Okay, to try to detect what we could find there.
Yes.
Right? Through spectroscopy, a NASA scientist, Dr. Carol Stoker,
yes.
on Mars found evidence of chlorophyll.
Yes.
Now, it's not strong evidence, but it's evidence. And that's just one other thing. And that was well past Viking. And if you're sitting there trying to track the progress of finding evidence for life on Mars, I mean, here, there's half dozen things here that we have to make the case.
Yeah. So Carol's a good friend. Okay. So absolutely we know the result. Keep in mind, let me just backtrack 2 steps here.
Sure.
Dimethyl sulfide.
Yes.
And it's the same thing with organics of the GC mass spec. When you fail to find something, you simply set an upper limit, which is related to your detection limits of your instrument, right? If I fail to find life living in that carpet because I can't see microbes, there's life in that carpet, but I can't see them. I have a detection limit for my instrument. One of the problems that they've always had with methane on Mars and dimethyl sulfide on Mars is that the amounts are so small that people can question the observation. Now, hey, I've questioned, that's what we did with the Viking gas chromatography mass spec results. We questioned their observation. We have said you failed to find organics, but you have a level of detection limit that you did not understand at the time that you ran the experiment. There are organics there, but you were not actually able to detect them at the part per billion, which is what you thought you were able to detect. So that's a fine result. And that will be how dimethyl sulfide and how methane will be dismissed in the culture if you come across somebody inclined to dismiss them. So that's a statement. But you're absolutely right. Look, I mean, what I found very annoying, and I think that's the correct word, about the standards document, which you have cited pieces from my comments on it, was that you discovered them writing 3 statements about why you needed to have a committee be a gatekeeper for the release of data that may indicate alien life, when that in itself is something, if you let the public know that NASA has a committee, let alone a government committee, deciding what can and cannot be published, that undermines the public's perception of the scientific process in a way that nothing else can. But then they have 3 explanations for why they need these standards. One of which is because if we had only had these standards, we would not have screwed up the Viking interpretations. There was another one which, if we only had the standards, we would not have misinterpreted fossil records from Central Australia, which were taken as indicators of very old 3.5 billion year old life on Earth. Now, Mark Harrison wrote a piece on Primordial Scoop, which pointed out why that was wrong. So you're in a situation where you're seeing people justifying the concept that we have to have a committee to decide what we can and cannot publish, using examples which are simply demonstrating that the committee does not know enough about the details of what actually went down in these cases.
Yeah, and the committee, your response to the committee, that the search for organics using the gas chromatograph mass spectrometer instrument did not support a non-biological interpretation of the labeled release results. You're basically saying they were wrong. Neither perchlorate nor chlorate can explain the Viking labeled release experiments. Wrong again. And we still do not have a solid non-biological explanation for the labeled release results, and we certainly do not have numerous explanations.
Yeah. Well, so the perchlorate's a wonderful case. So as I said, I could set things on fire with perchlorate and do if my 4th of July fireworks device goes off. But, you know, they tried to oxychloride species to explain Gill-Levin's result, but Gill-Levin's results were not run at 400 degrees centigrade. These were at low temperature, and perchlorate and Gill's food at low temperature don't do anything. They just sit there. There's a question, and there have been experiments whether the rocks on Mars, limonite, these are iron oxides on Mars, whether if you expose them to UV light or whether if you put peroxides on them, will they reproduce Gill-Levin's experiments. So it would be a perfectly reasonable thing to set out now and try to get the best samples that you can get from Mars and try to see if you can find some plausible explanation for Gill-Levin's experiments, respiration, but not be it biological. That would be a reasonably good line of research. Now, we don't have a lot of samples of Mars. Of course, we don't have any samples of Mars from the Utopia and Chryse landing sites where Viking went. But yeah, I mean, I was quite surprised that after 40 years, okay, including our paper in 1999, but saying that the GC mass spec result did not rule out organics, but never mind the fact that there have been rovers down there since for years finding organics. It surprises me enormously that you could have a committee sit down and say, hey, we need this committee because of the Viking results, when the committee themselves clearly does not understand the Viking results. But hey, that's culture. Culture is what you think when you're not thinking, right? It's what you do automatically.
One more thing about the gas chromatograph mass spectrometer. According to Barry DiGregorio, in his book, he outlines the history of the mission in exquisite detail. This test, along with the labeled release experiment, tested samples from Antarctica.
Yes.
Labeled release experiment found microbes.
Yes,
Okay.
absolutely.
It was, as I understand, it was a perfect test. It never failed.
Well,
It never produced a false positive nor a false negative. Okay,
Yes.
but that's besides
Yes.
the point. The gas chromatograph mass spectrometer, as I understand it, wasn't even able to find organics in Antarctic soil.
Yeah.
If it can't find organics in Antarctic soil, and they knew this,
Yeah.
they knew that they were there,
Yeah.
but they send this thing to Mars anyway, knowing that it wasn't able to find organics here on Earth.
Yeah. Well, that GC mass spec was not intended to be a life detection. It was not sent to Mars as a life detection instrument. It became a life detection instrument afterwards.
Right.
So,
But if it couldn't find organics on Earth,
yeah, you would still send it for other reasons, because you wanted to know what organics you could find to the limit of detection, right? So the machine, it's right. I got
they're
it.
basing their entire conclusion
That's
off
right.
of that result.
That's correct. Well, the logic is quite simple, right? No organics on the surface of Mars. I mean, I gave you the syllogism. All life requires organics. There are no organics on Mars, therefore there's no life on Mars.
I get the conundrum.
Fine. Then the question, then you have to go through, but there should be organics on Mars because they fall from meteorites all the time. Where did they go? Well, there must be an oxidation. Okay, if there's an oxidation event, now now that oxidation doesn't have to be very aggressive, right? You have millions of years, a little bit of organics come every year, but you have millions of years to burn them before Viking arrives. And so it can be a mild oxidant, right? But that mild oxidant won't explain the speed with which Gil Levin's food was oxidized.
So the oxidant explanation doesn't hold water.
That's correct. Okay, but let's go back and now let's have some fun. Okay, so if you want to have some fun, you are going to be now disciplined. And I'm going to say to you, okay, come up with a scenario for the biological side of this, right? Because you've heard a lot about the non-biological. Yeah. That's an interesting problem, right? Because I've sprinkled food on you, and you exhale it, and you exhale carbon dioxide. Where did you get the oxidant to exhale the carbon dioxide? Well, the answer is it's in the atmosphere around you. You inhaled it. That's where you got the oxidant to burn the food. Now let's go back to photos. So I've got it. Let's just now try to build the biological model for this.
Yeah.
So Gil Levin's results is respiration. He treats that as analogous to respiration of life on Earth. Life on Earth, however, has oxygen from the atmosphere to do the respiration. Where does the oxygen come from on Mars? Well, there is no atmospheric oxygen on Mars. Well, there's not much.
Tiny,
right?
Not much.
But the point is that nobody asked the question, where did the oxidation come from? If it were a biosystem, a lot of people eventually went back and asked where the oxygen came from if it were an abiological result, and that was coming from hydrogen peroxides, and they were sometimes not very descript peroxides, sometimes they were UV activated peroxides, sometimes they were radiation activated. A lot of them, but nobody asked the question, well, if it's a biosystem, where did the oxygen come from? Likewise, with photosynthesis, this is the lecture that you perhaps saw in Tempe at the Mars Society meeting, right, where we asked, are you smarter than a sixth grader? So if you say a plant sits out there and they take in sunlight, they take in carbon dioxide, they make or reduced organic molecules, and they exhale the oxygen in the atmosphere. So the question is, what do plants do at night? Well, the answer is they respire. Okay, so what they do is they do the same thing that you do at night. They have food that they've stored up from the day, and they take in oxygen from the atmosphere, and they burn it, and they do metabolism with the energy that they get from it. Now, the question is, what do the Martian photosynthesis organisms do at night? If we interpret now not the results as being abiological, but the results as being biological, well, I don't know, they respire. But wait a minute, they don't. When I have a plant here on Earth and I throw a molecule of oxygen into the atmosphere in the daytime, I know I can get it back, not the same molecule, but some molecule of oxygen at night. But in Mars, if I throw away oxygen after I do photosynthesis during the daytime, I have no reason to believe I can get it back at night. So what plants on Mars must do is they must store oxygen for overnight metabolism. Okay, now, so here I am, a plant sitting there on Mars. I don't have an oxygen atmosphere, so I'm basically making a combination, which is the distinction between jet fuel and rocket fuel, right? Jet fuel, if I fly to Los Angeles from DC, I get the oxygen from the air, right? If I go into outer space as a rocket, I can't get the oxygen from the air, so I carry with the oxidant as well as the reductant in my. And so a plant on Mars has got to sit there and store the oxygen as well as the reduced carbon to survive for the night.
And when you say plant, you could just mean microbe.
I'm assuming it's a photosynthetic microbe.
Okay.
Hence a plant.
Okay.
But don't get me wrong. Plant, you're right. Your audience might think that a plant is a multicellular plant like what's sitting over there in the corner, and that's not what we're thinking about on Mars. Absolutely. It's a photosynthetic microbe on Mars. Mm-hmm. So now the question is, great. So if I'm sitting there, I'm a microbe sitting there on the surface of Mars with very sparse water, problems with the solar energy probably, and I'm sitting there and I get do a little carbon dioxide fixation, make the stuff, and I store oxygen for night, and then some clown lands a spaceship on my sunroom and
you hit
starts
the lottery.
dumping water. Well, what am I going to do? I would release the oxygen from the. I mean, it's the same thing I do with you. You actually store oxygen as well. It's in hemoglobin. And, it will be released. So what they do is one of the oxygen or the gas exchange experiment, it was called, was they put water on the surface of Mars and saw the release of the O2. Now, the non-life people say that's the peroxides that are there to toast all the meteoritic organics and going to toast Gil Levin's form in an abiological but, if you're going to be, now the dialectic says, okay, let's worry about the biological model for the same result. That's the oxygen these plants are storing for overnight metabolism. Mm-hmm. Okay? And then Horowitz does a much better experiment, and he'll tell you it's a much better experiment in every paper he's ever written. All those first two experiments put water on the surface of Mars in non-biological amounts. Horowitz just puts CO2 and a little bit of carbon monoxide, which is coming in from the natural Martian environment. He does not put liquid water in any quantities onto the surface of Mars. So he argues that his experiment does not perturb the environment as much as Gill's experiment did in the oxygen exchange. So all he does is puts radioactive carbon dioxide, a little bit of radioactive carbon monoxide above the surface in the ratios that they're found in the Martian atmosphere before Viking got there, and he sees the fixation of carbon into the surface. Now, the non-biological explanation has there is no non-biological explanation for that. They can't come up with one. One of the explanations was maybe the carbon monoxide does react with UV light to form organics, and it does, which is why they did not use solar UV in that experiment on Mars. They blocked the sun out, and they generated their own UV device to cut off at a wavelength above the wavelength in which carbon monoxide would be fixed. They saw carbon monoxide, and poor Norm writes in his paper, well, we got to go back and find out some way of fixing carbon in the atmosphere, from the atmosphere into the surface of Mars, because it's an anomaly, we can't explain it. But then there's another problem. If you believe that the surface is so oxidizing, it's got such a powerful oxidant that it's toasting Gil Levin's food in minutes. And then you believe Norm Horowitz's experiment, which says we have reduced carbon dioxide from the atmosphere to make food, which we recover after days. Why isn't the organic oxidant that is present in the Martian soil that is burning Levin's food not burning the stuff that Norm Horowitz is fixing into the surface? It sits there. Now, in a biological model, you say, oh, well, if I'm a life form sitting there in a watered, sparse environment, I'm going to wait. When I get water in from somewhere by accident, a little bit of regolith melts or a little bit of glacier, I want to be ready to do carbon fixation. So I will absorb CO2 from the air and store it actually plants do. There's C3 and C4 plants. They have different ways of managing it. But I'm going to sit there and I'm going to bring in, when Norm gives me C14 labeled carbon dioxide, I'm going to just store it in anticipation of my having a moment of opportunity to reduce it into something that I can use in my metabolism. So you can go back and say you have bacterial autotrophs, okay, respiring with stored overnight oxygen for overnight metabolism is the model for photosynthetic microbes on the surface of Mars that would account for all the experiments. And so now you've got the biomodel and you have the abiological model, both of which have defects, some of which I've just pointed out to you. And now you put them let them fight.
Okay. I take it you don't make many enemies in the community.
Oh. No, we make enormous numbers of enemies in the community.
Yes, but you seem to have this really diplomatic way of phrasing things that doesn't point the finger too much.
You would be amazed at how many enemies I have in the community, yes.
Because what you're saying here, to the layperson, you have a lot of technical information here, but what you're saying is that, well, those people who think there's a chemical reaction or an oxidant explanation, that there's really no strong evidence, really hardly any evidence to support what they are saying. You're saying that they're wrong.
Well, that's right. So,
and that's
a complicated statement, right? Because your first problem is that I can find ways of burning organic food, what Gil Levin put on the surface of Mars with perchlorate if I heat it to 400 degrees centigrade. But perchlorate ceases to be an explanation for Gil's experiment at the temperature at which the experiment was run. Okay? So a lot of people have, Richard Quinn, for example, has come up with models whereby you put radioactivity onto the surface of Mars with perchlorate and you generate species that will oxidize Gil Levin's food. But then you go back and say, how much radioactivity did Richard use? Well, the answer, he used 10 to the 12 times more radioactivity coming in from cosmic rays and actually gets to the surface of Mars as cosmic rays. And if you do a linear extrapolation, by the way, there's no reason to believe that the extrapolation is linear, but if you do one, you don't explain Gil Levin's results that way. You have hydrogen peroxides on limonite. This is an iron oxide mineral, which will toast Gil Levin's food. But then the question becomes, where did the hydrogen peroxides come from? And you got to keep in mind that iron will cause the destruction of hydrogen peroxide without food over the period of hours or minutes. And so we now have displaced the problem from how do we oxidize Gil Levin's food to how do we get the hydrogen peroxide on the limonite to do the oxidation.
Okay,
so you have to put a big chart up on your wall with all the little connections and all the little things. And at the end of the day, I don't see a coherent non-biological explanation for any of these results. And of course, there's a back and forth, perhaps you saw on Primordial Scoop, there was a cartoon of a Thanksgiving debate between Jan Spacek and me on the Barsoom model. That is, by the way, bacterial autotrophs doing respiration using stored overnight oxygen for overnight metabolism, which happens to be Edgar Rice Burroughs' John Carter, Princes of Mars, named for Mars, but was an accident. So we fought. You can go back and you see Jan, me going back with consecutive posts arguing this out as to whether Benner has violated deep principles of science by using the data that he knows to construct a model which is consistent with the data. You could make the argument that it would be cleaner if I had constructed this model without knowing the data, and then the data come along, and then I can say, first principles, I got the model.
Well, I have a feeling you wouldn't have posted that had you felt like you lost your case.
Well, I'm a very open guy in this respect. So you can read it back and forth. And one of the things that Jan and I did not do is we did not edit our posts in response to the post that followed. So, you have a fair back and forth in that.
See, this is what I'm talking about. You're real nice. You outlined, okay, as a serious scientist would, all right? You take a look at the life test results and you say, okay, let's examine this from the biological explanation. Let's also go ahead and entertain the non-biological.
Our best model with life and our best model without life.
If you had to put your money on one of them.
Well, I'm in a sense an advisor.
Blah, blah, blah. Where would you put it?
Yeah, I would send a mission to Mars with a specific serious life detection. But I'm spending my money at this point, right? I mean, obviously I'm a taxpayer, so I'm only...
You think it's definitely well worth following up on this question?
I believe that the only thing that NASA should be doing right now, I mean, obviously NASA has very limited resources. And you got to keep in mind that NASA has a science mission as well as an astrobiology mission. So there are reasons why NASA wants to go to outer planets and inner planets and all the rest of it.
Yeah.
Paul Davies has just written a wonderful piece basically saying that NASA justifies everything, including its mission to Titan, as a search for life in some sense or another. But they are not doing the one thing that is the most important thing to find life where it's most likely to be found.
Well, let's talk about
going
that.
To Mars.
Because there's the phrase, follow the water.
Yes, indeed.
Okay, I get it. We've got these icy moons.
Yeah.
They most likely have they have this ocean underneath.
Yeah.
Okay, of this ice crust. Certainly, if it's liquid water, and a lot of it, we could expect to find there's a high probability. Follow the water.
Yeah.
Where do we go? We go to see
Europa
and Enceladus,
yes,
right?
Absolutely.
Because there's a higher likelihood we will find life
there.
there.
Enceladus is spewing the water out into space, so you don't have to
No doubt we should go.
Yeah.
They're way out there.
Yes.
Mars is right next door.
Yeah, I'm with you.
Okay? It's got water, ice, in many locations.
Yeah, I'm with you.
Okay?
Yes.
Professor Hoover, all right,
Yeah.
says if we send another life detection experiment to the polar ice cap of Mars, he says 100% chance we're going to find life there.
Look, I've been on committees. I was on the Space Studies Board. I talked to people like Yuri Milner. So Yuri Milner is one of the PayPal billionaires. He runs a breakthrough organization. We say to him, he wants to go to Enceladus. Chris McKay and I spent a lot of time talking to Yuri about going to Enceladus. I say, no, Yuri, go to Mars. And he says, Mars is taken. I'm not interested in Mars. NASA's going to. So we talked to the Schmidt Foundation. So, Google, he has funded work in our laboratory on Venus. Say, go to Mars. He says, oh, Mars is taken. I want to go to Venus.
Meaning that NASA's...
The view of the private organizations, the private entities, these are people who are saying that Mars is an obvious source, a place to go to find life, that we want to...
There's already too much interest there?
There's already too much interest there. And so
there's not.
But there's not.
There's interest now in sending people there.
Yes.
Okay, NASA, it seems like they're just teasing us because they seem, well, we're going to go to Mars. This is another misconception. Okay, again, I talk with scientists all the time. We're sending rovers all the time. We're sending missions to Mars all the time. What do you mean we're not looking for life?
Yeah. Okay, so to give NASA a little bit of credit, which I do every now and then, but they did have a decadal survey. So in 2013, 2020, 2012, then 2022, 2023, they did a decadal survey. At some point, somebody in that room said, wait a minute, we're talking about all the missions that NASA is interested in, but no one has talked about a Mars life detection mission. In 2019, Michael Meyer, who is he's a Mars mission specialist at headquarters in NASA, he got a conference of people together right before COVID in Carlsbad, maybe 50 people, and we wrote a report. And the report basically said not only that we think there's extant life on Mars, but where we would go look for it, where there might be refugia in caves or in, near the ice caps in various places to find it. This whole report. Now, I've written a lot of reports for NASA. I wrote a book for NASA, right, with John Barris in 2009 on the search for, when I was on the Space Studies Board with the National Academy of Sciences. You write a lot of books, you write a lot of white papers, write a lot of pamphlets, and they don't usually go anywhere. But the bottom line is that there it is. So Amy Williams, who's now at the University of Florida, led a team which went back and tried to do Mars decadal survey analysis for the search for extant life on Mars. They are constrained budget. Amy is told, hey, you cannot spend $1 trillion. You have to, there's other issues going on. And so you can go read the decadal survey. It's there. There's now a plan looking for life, extant life on Mars. That plan might be implemented in 2042.
This seems so easy.
Well,
to send
nothing's easy, right? We can't get the instrument to work. We send stuff
there all the time, and it works because those engineers are great at what they do. They can get something to land on Mars. We've got we got a great track record of landing stuff on there. Okay, now as I understand it, you send a video microscope there. You stick a slide. Here's where you have to credit Wolf Fishnack.
Yep.
Okay, as I understand it, he unfortunately passed away in Antarctica on an expedition searching for life down there. But he had this technique where he just stuck a glass slide in the dirt, came back a few days later, pulled it out, looked at it under a microscope, and boom, he's got stuff growing on it.
Yeah.
Okay, that's all we got to do is send it there, slide, put it under a microscope.
Yeah, look, obviously Mars is not as far away as Enceladus. But it's still, and it's a little more difficult than that.
I know they're budget constrained.
Well,
but we are talking about answering, again, this very most fundamental question in our history.
Yeah, no, I got it. You are expressing a frustration that I hear a lot from the public, and that is that Mars is constant. There's a great Star Trek line,
but they think we're looking for life. Like it's like. When we went to Mars in the 70s, we're looking for life. We've got these life detection experiments, okay? They keep saying we're looking for life, but they're not really.
Yeah, that's Paul Davies' editorial.
But people think we are because we're sending these helicopters doing all this cool stuff.
Yeah, I find the helicopters
Dr. Benner, we're sending helicopters to Mars. Yes. Surely we're going to find life with the helicopter on Mars.
No. Don't call me Shirley. But yes, no, the answer is, of course, they're not sending there. The helicopter mission was designed expressly to say, we want to demonstrate that we can prove that we can fly on Mars. And that was how the mission was justified. And the argument would be then, why do you want to prove that you can fly on Mars? Well, the answer is, okay, it has not a lot to do with life detection, but you can go in principle, explore in a space around where you land to get away from the space that you have contaminated because you landed there, as well as maybe to go towards a cave or something like that, which would be one of the refugia that is put together in Michael Meyer's 2019 Carlsbad Conference report. But look, keep in mind that I disagree with Richard Hoover and with you in the sense that what happened in Viking was we learned something about how we were supposed to search for life. That is, we try something, we did our damnedest. I had nothing to do with it. I wasn't scientifically active, but we did our damnedest to try to come up with a reasonable set of experiments. We got there, we did the experiments. In one case, a valve failed to open. There's the whole usual range of experimental issues. The results were somewhat perplexing. But because of the GC mass spec misinterpretation, the follow-on mission did not do what one would normally do if one had not misinterpreted the GC mass spec result, right? What they should have done was taken what they had learned. I mean, Gil, there was this question about left-handed and right-handed food. I don't know whether you found that lactic acid, which we've already talked about, is left and right-handed. They should have put left and right-handed food onto the surface.
They should have sent a follow-up.
Yeah. Well, they didn't do. They were aware of that at the time. There were budgetary constraints. They didn't.
We've
do
had
it the first
50
time. They should have sent a
years.
follow-up. Yeah, I got it. I'm with you. But then what happened?
And they didn't allow him to work with the Russians.
Well, they did. I think they dropped one of the rockets into the Pacific Ocean, if memory serves. there was one failed launch attempt, which was...
Or rather, they did let him work with the Russians in a very limited capacity, but they would not let him put the labeled release experiment.
That's right. There was some politics involved, and there was also a failed launch.
Right,
but,
politics and failed launch.
But never mind. The bottom line is that what happened then was what? Dave McKay, not to be confused with Chris McKay, found fossils, in quotation marks, in an Allen Hills meteorite from Mars, and that brought Bill Clinton, President of the United States, to the stage.
Right.
When was the last time a scientific result? I mean, if you cure cancer, will it bring the president to the stage? This is big time.
Right. So one would think in the wake of that, let's refocus our efforts on answering this question definitively. Yes. And still, NASA seems like they dropped the ball.
Well, okay. I mean, I go back and forth between defending NASA and not defending NASA. So the argument here is actually not subtle.
That's why you're a nice guy.
What?
That's why you're a nice guy. You're likable.
Okay. Well, the argument's not. No, it's an essential part of the dialectic. The philosophical process is taking both sides, and only if you take both sides, you actually know what the sides are. And that's a very useful process. But the argument, of course, is that look. In 1976, the Viking results came in. There was a whole bunch of people employed at Jet Propulsion Laboratory. There was a whole big operation going on. And within weeks, doors were closed. People were fired. The labs were shut down. This is a government program. You never close government programs. Here they close government programs because of a particular failure. And the interpretation at the time was that they promised too much, right? We promised that we would go look and detect life on Mars. And the mistake that was made, this is the interpretation, is that by promising that we would go look for life on Mars, we did not give the public sufficient amount of warning that the results could be ambiguous. Hence, follow the water. I don't look for life, I look for habitability. Okay? I look for water.
This is gray area here. People don't like gray area.
Well, but I can get it. I mean, I think it doesn't quite...
You're saying NASA wanted to avoid another public relations mishap.
Look, I didn't say that exactly. What I'm saying is that NASA, I think, presumes that the public cannot anticipate or tolerate ambiguity more. And remember, NASA is just as a building administrator, right? We're talking about the community.
Yes.
So if you read that standards report, that community standards report is dripping with the sentiment that the community has to be careful about giving the public incorrect information, because it will, if we give them incorrect information, if we reveal ambiguity, if we don't answer questions clearly, the public won't tolerate it.
Yes, but we now have trained scientists, astrobiologists, okay, who aren't up to date. And they are of the opinion, of the perspective, that there is no evidence.
Yes. Okay, I'm a little worried. You have gotten me concerned when you said that you have talked to astrobiologists who don't know the difference between proof and evidence. Now, I want to know their names off camera, and we'll go talk to them.
That's what I'm saying.
Well, that means we're failing in our education of
They have degrees. They got a Ph.D., just like you.
Yeah, well, okay. I mean, I'm of the opinion, I'm a very strong person that the word proof really should never be said.
And I don't use it.
Outside of a mathematical context where we're talking about real proof.
Right.
Right. You have evidence, and you have evidence of various strengths, and your perception of the strength of the evidence is very much dependent on your culture. That's how I look at the world. But you try to apply that to yourself, of course, as well. But look, I mean, yes, Jan, when we certainly talk about this, is of the opinion that the only way that we will have an extant life detection process going on Mars before humans get there is if private individuals fund it. Of course, there's a lot of private individuals interested in going to space. Elon Musk, Jeff Bezos, everybody who got a lot of money, right? This is the difference between men and boys, is the price of their toys. But hey, if you're rich, if you've made a lot of money, what should you do with it? Well, I think finding life in the galaxy is not a bad way of spending your resources. So yeah,
Avi Loeb agrees with you.
Yeah, that's right. Avi certainly does.
He's put together another
Copernicus space. It's in Jacksonville.
Yes, and they're interested in going to Mars as well.
Yeah.
I don't know the mechanics or what.
Well, Frank Laukian is who ran Brooker, who is a big NMR company, a very important medical instrumentation company that Frank built from. Well, his father has founded it, but Frank was the guy who actually built it. He's funded some of this, but of course there has to be money. And of course, the minute you start going to space, a launch is $100 million or something like that. Now, Jan has a project idea called Impress, which is going to try to use what Copernicus does, which is to crowdsource. So instead of taking $100 million for a launch for one device, you drop onto the surface of Mars penetrators, where the cost of the landing is not very high. You basically just drop a rock onto the surface of Mars, and you construct the instruments so that they can tolerate the impact. And so that might very well be something that goes along with the Copernicus concept. But you're right. There are lots of people, and I can't think of a better way to spend my money. We get money from royalties for medical innovations, and I put them into Mars life detection. So what can I say? I mean, it's just part of what we do.
Another thing that I found kind of curious, let's just put it that way, when speaking to astrobiologists, they say, well, we don't know what type of life.
That's right.
What extraterrestrial life would look like, so we don't even know how to look for it.
Yes. Well, that's what the agnostic life finding is all about.
And I'm thinking, look, you guys are smart people. Surely you can figure out a way.
Yeah.
And then, yes, you were talking about in your presentation a way of looking for life agnostically. What do you mean by that?
Yeah, exactly. So one of your questions, I mean, my big research view, what I do in my career is try to merge natural history with physical science, right? I mean, these are two very different traditions in science. The molecular biologists don't think that the organismic and evolutionary biologists are really scientists, right? There's a great opportunity to merge these two. But absolutely. So what we did as synthetic biologists was to say, okay, if we're so smart and we understand how life works at the molecular level, we should be able to make molecules that are different from DNA that do what DNA does. Right? So that's a synthetic approach to understanding. If you don't, this is like in a Feynman line.
Well, you've created alien DNA.
Yeah, so we make alternative forms of DNA. So it's a Feynman line. What I do not understand, I cannot make, or what I can make, I understand, or something like that.
Yeah.
So we set out to try to find out what the universe of possibilities was for genetic information storage molecules.
Okay, but isn't it possible that a microbe on Mars could have the same genetic structure as a microbe here on Earth?
But we also know that it's possible it could be different.
Of course.
Yes.
But we should also include the possibility that it could be the same.
Yes, okay.
Fundamentally, why rule that out?
Well, we certainly rule it out, but if I'm going to spend $100 million of taxpayer money to go to Mars, I want to be able to get them both. Yes,
of course.
Exactly. But it's very useful. When you try to make alternative forms of DNA, sometimes you succeed, and sometimes you fail. And when you fail, you learn something about what DNA-like molecules must universally have as structures. And one of the things that has emerged from this is called the polyelectrolyte theory of the gene. There's a Wikipedia article that Dave Catling's student. So the argument is that informational molecules may have different bases, GACT, may be different. It may have different sugars. It may have different other features, but they will all have a repeating charge in the backbone. Now, if I say that Klingon DNA, Vulcan DNA, all DNA will have this particular structure, Martian DNA, even if it has a natural history different from Earth's life, it originated in a different way, it has different billions of years of evolution, it will have a genetic informational molecule that has a repeating negative charge. When you do synthetic biology, what you're doing is creating in the laboratory, by chemical synthesis, alternative forms of molecules that you think might be able to have play the same informational role as the DNA does in your body and mine. I mean, everybody agrees that life has to have, whether everybody agrees, one of the distinctive characteristics of life is that it is able to do Darwinian evolution, that is, have babies where the babies are a little different. You make replication with errors where the errors themselves can be replicable. And that gets you into this natural selection, Darwinian evolution process. And the question is, what kind of molecules will support that, the informational needs of that process? And so we've made lots of DNA molecules. Your DNA has 4 different building blocks, G, A, C, and T. We've made them with 6 building blocks, 8 building blocks, 4 different building blocks, different scaffolds on which you put the building blocks. And sometimes they work and sometimes they don't. And when they don't work, you say, I've just screwed something up. There's something wrong with my molecule, which means it will not be able to store information in a replicable form, or replication can occur with errors that are themselves replicable. So one of the universals that comes out of that is that the DNA molecules that will be universal, that is, they may have different numbers of building blocks, they may have different kinds of building blocks, but they will all have a repeating negative charge or a repeating positive charge. They will have a repeating charge. And that's quite nice, because if I have a sample of Martian water, let's just say, and there's life in there, it's got informational polymers, and we know from a lot of work in synthetic biology that they will have a repeating charge. Now, if I put a positively charged electrode over here and a negatively charged electrodes over here, the Martian DNA, if it's like Earth DNA, will migrate towards the positive electrode, or if the Martian DNA is like positively charged in the backbone, it will migrate to the negatively charged plate. And so what you do is this universal polyelectrolyte theory of the gene, this universal statement that informational molecules for all life, dependent on Darwinian evolution, which is all life, according to theory, will be able to be concentrated from sparse, highly dilute solution by putting this in an electric field. So what Jan Spacek and his team are doing is putting together a device that will sit astride Elon Musk's water. What's Elon Musk doing? Well, Elon wants to pump water out of the ground for humans to go to Mars. Well, what does water do for humans? Well, we can drink it, but the most important thing he's going to do is make propellant out of that water. He's going to run electric current through that water, make hydrogen and oxygen. He's going to use the hydrogen to make methane. And Matt Damon is going to return from Mars in a methane oxygen Raptor rocket. And that's how made from water that is mined on Mars. So the idea, goal, and this is the NIAC NASA project that's being funded right now, is to have Elon's flow of water to make propellant sit astride will pass through plus and minus charged plates to concentrate out the polyelectrolytes as a universal and agnostic, meaning that it will be independent of the natural history of life on Mars as an agnostic life-finding biosignature.
I just get the feeling when I'm conversing with those about the possibility that we find evidence for microbial life on Mars, that because there's been this deep-rooted narrative that Mars was found to have no life, and that we don't know what life we could even possibly be looking for, what that would look like, as we just discussed, that it's not even worth taking a second look at Mars.
I'm going to ask you off camera who you were talking to, because I will have a word with them in my free time. Look, yes, there is
And
institutional imperative.
One extra thing.
Okay.
I've even spoken with a gentleman. I'll tell you who he is off camera, but another one of these credentialed experts, all right, point blank, he just said, Mars never used to be like Earth. Mars was never like Earth. And I'm thinking, you call yourself a scientist of this particular discipline, planetary science, and you're of the perspective that Mars never even used to be like Earth.
Well, I mean, I have to parse this statement. Like, what's the meaning of the word is? I mean, never like Earth. It never was the same mass as Earth, right? There are ways in which Mars was always different from Earth. It was never had the orbit of Earth. I would basically have to go back and press the gentleman or lady.
But this is the culture that I'm running into, that you speak of.
Yes.
How do we have a conversation with these folks without sounding like we're on the fringe?
Well, I like being on the fringe, but again, I'm a little surprised. I mean, you understand, I can say that Mars was never like Earth in the sense that it was never identical to Earth. It's always been colder and drier, and it's composed of accretion farther away from the sun and the solar disk than near the Earth and the solar disk, so there will be a different overall redox potential of things. And so, yes, so I can come up with all sorts of ways in which they were different. The question that you can ask is whether or not there was ever liquid water in an atmosphere of some kind on Mars, I think is relatively under control. And
how do you distill down Mars's history?
Yes.
Okay, if you say to them, Mars was always the way that it was, now we know that's not really true.
That's right.
To boil it down to something that they could understand in an instant, hey, guess what? Did you know that based on the evidence, Mars actually used to be a lot like Earth? Well, and that's something that even scientists today are so sensitive about.
I don't know that this helps, but Earth is not like Earth, or used to be not like Earth in the past. I mean, if I go back 3-4 billion years into Earth's ancient history, it's not like Earth today, right? Among other things, you don't have all this oxygen in the atmosphere, and this oxygen is poisonous to lots and lots of things. And the first thing that you had to do once these plants started to make photosynthesis, where water was used to reduce carbon dioxide, and you threw away the oxygen in the atmosphere, this poison, you dumped it into the atmosphere, right? The first thing you had to do was become resistant to the oxygen. And of course, you have come to be quite resistant to it and to use it for good things. But yeah, I'm surprised a little bit at this. I mean, there is an interesting question as to expenditure of public resources, okay? Do I spend a lot of money to go to Mars? Now, remember, NASA is, in some sense, highbrow entertainment, right? It serves a role in American political culture as to boldly go. It gives the students, kids, motivation to study science. That gives the public that participates a sense of mission, right? All of this, and frankly, you can go to popular culture, Star Trek, Star Wars.
They've had a positive influence on us, for
Absolutely.
sure.
Yeah. So there's no question in my mind that NASA's money is all very well spent for all of those reasons, not the least of which is enthusing kids about doing the hard work that goes into learning how to solve differential equations. And, you know, this is, and it's also important to have kids do the difficult discipline that is required if you're going to be a successful scientist. It's hard work. And, you know, I mean, I don't know how, I don't want to ask you how many science courses you took and whether you like them. I mean, I'm hoping that you got some that were not horribly taught as gatekeepers for medical school, but that's another question for another day. Yeah, look, NASA this is highbrow entertainment, not World Wrestling Foundation. This is how you appeal to the educated public, and they are very much interested in life. And unless, I mean, don't get me wrong, Hubble, the James Webb Telescope, like these pictures are providing to the public benefits. Every dollar that they spend on this, it's wonderful
NASA's done amazing things.
Yeah, it's and in some sense they have basically, well, NASA's done such amazing things that cause us to expect it as a matter of course, which is really unfair to the
Right. Well,
scientists
we
who do
have
that.
high standards for them based on their magnificent
Yeah,
work.
they produce magic. Oh, you got to keep in mind, my father-in-law was a guidance guy on the Apollo moon landing. So I mean, these are all young men who had computers roughly the size of what's in a tenth of your watch there,
Right.
who put men on the moon. It's a remarkable statement. But the bottom line is, look, I don't quite understand who you're talking to, and it worries me if there's a statement that scientists don't distinguish between proof and evidence, and I am going to have to go back and look at it.
They are absolutely afraid. And it seems like this question about life, specifically on Mars, seems like it opens up a can of worms they just rather not address specifically. So they try to obfuscate, they try to just downplay, they try to do whatever they have to avoid talking about the specifics. And it seems like in most cases, they're not even aware of the specifics.
Well, you're going to have to do, you're more important in this than I am in this context, right? You have people, private individuals, who are able to mount a serious space mission.
Yeah.
We have to persuade these people that Mars is an appropriate target for their activities. And obviously, Frank Lalkin is somebody who's on board here. Jeff Bezos, I don't know. Yuri Milner, I've talked to at great length about this. You know, it's...
Put me in touch with Yuri.
Okay, I'd be delighted. The point will
I'll
be...
talk to Yuri.
Yeah, you can talk to...
I like Yuri.
Okay.
He's a visionary.
He is very much a visionary, extremely so. And in some sense, that's part of the problem, because Mars is not of much of a vision for him, right? Enceladus is much more... But look...
Maybe he should watch my movie.
Yes, that I would recommend everybody actually watch that. That movie is wonderful.
Well,
but the bottom line is that Enceladus is 10 times the distance from the sun as Earth. The solar power that you're going to get, therefore, by the square law, is 1% the solar power on Earth and Earth orbit. You can't, therefore, really power anything at the Saturn orbit. There have been people who say, well, we'll take reflected light off of the rings of Saturn to boost the power. But then you have to have nuclear fuel to go there for. The United States has maybe 1 or 2 missions of plutonium left. They're not going to give it to Yuri Milner to go fly a private mission to Enceladus.
Right.
So
Yuri, come on! It's too hard.
Mars is there, and then the problem with Musk, of course, is first place Musk is hopelessly distracted. I mean, he's into everything at this point. He has the Boring Company. He wants to put tunnels beneath Miami and stuff like this. But yeah, I mean, Musk wants to put humans on Mars. And of course, we're trying to persuade the organization to say, well, maybe at a no-cost or a low-cost add-on to your water mining operations, we could, detect life on Mars. But then, of course, you got Barry de Gregorio's problem. So Barry's afraid that Martian life will come back to Earth and eat us. Mm-hmm. I think that's misplaced. I have, as I was telling Ginger, we have 5 grams of Mars sitting in my office, which a donor to our organization helped us buy. This Martian material comes with maybe 500 kilograms a year, cold.
But the stuff that's falling to Earth,
yes,
arguably, one presumes that it's been out in space for a while.
Yes, it has.
It didn't come directly over 6 months from Mars. So it's been out there possibly, the conditions of space
we know
is harsh. Certainly inside of a meteor.
Right.
Okay, yes, we would expect really the extremophiles, they have the possibility to survive, but on the surface, so it gives it a long time for these things to die off and perhaps even fossilize.
So with the Allen Hills meteorite, all these dates. The date it was formed by radioactive uranium lead date isotope. It's ejected. You have minerals whose magnetism would be reoriented if it got above 70 degrees centigrade. They've not been reoriented.
But all this to say, by the time it reaches Earth.
Right. We know how long it's been in space by looking at the isotropic
Yes. Well, what is the
bombardment.
likelihood that anything survived?
Fairly high.
Fairly high.
Yes. Oh, yeah. I would expect. Right. I'm basing this on Earth organisms that are tolerant, dormant when there's deprived resources and so on. The rock's big. I mean, I don't know, if you go to central Maine, you can come across a museum where the guy has gone out of his way to collect all the Martian rocks he's got. He's got a piece of Mars that big in it.
What's this guy's name? Museum in Maine, huh?
Yeah, I have to look it up for you. But there's a nice tourmaline mine in Maine, which has made a couple people very, very wealthy, and they decided to use their wealth to get a fabulous meteorite collection. But it's near Bethel, Maine. It's in the center west part of the state. So I'll give you the address.
Yes,
It's a marvelous place.
Well, the current fascination with Mars among most of the general population.
Let me just repeat the point.
Sorry,
So to finish the point is,
Yeah.
I'm not all that concerned about NASA adding a few kilograms to the material that has moved from Mars to
Right.
Earth over what has already moved and
Right.
leading to contamination of Earth. I'm much more concerned, of course, about our going there and fouling up the science.
Sure.
Although I've talked to Antarctic explorers and they say, look, when we go to Antarctica, we're here in the base camp for maybe a kilometer around, you have signs that we are here. But if you go 10 kilometers away, there is no evidence that you've had humans at that spot. So, I'm not
So
quite
you're of
so
the
concerned
same-
about planetary contamination as Barry
Right.
is.
You're of the same perspective as Robert Zubrin. That
Yes, absolutely.
He calls it as if the Red Death would have come to Mars, would have come to Earth from these falling meteorites. It would have come a long time ago, and it would have made its impact.
Absolutely. And I've co-authored papers on this point with Robert. So we've...
Sure.
Yes.
And there's, that makes intuitive sense. But to Barry's point,
Yeah.
if there is evidence for microbial life currently on Mars today, as we've discussed throughout, isn't it in our best interest just to figure out exactly, number one, to confirm
Yes.
whether yes or no, and number two, what kind is it?
Yes.
Just to make sure, because the next question is, how do we ensure astronaut safety?
Yeah.
Because with the moon, it's sterile.
I guess. I suppose.
Based on our
Yes.
latest understanding,
Yeah.
the moon we think it's sterile, but Mars is different because it does have a little bit more of an atmosphere. Okay, we do have these these pieces of evidence. So Professor Richard Huber, he'll say, it's called due diligence.
Yeah. Okay.
Before we send astronauts into harm's way, we got to make sure we know exactly. And this is NASA. They examine everything from every different angle just to make sure they have backups and contingency plans and just what if scenarios. So how do we send humans to Mars safely?
Well, I mean, Chris McKay actually has said a point to me which I take into heart, and that is the people who go to Mars are going to be spending a hell of a lot more time surviving than they are going to be spending exploring. So the interface between the Martian biosphere, such as it is, and the human biosphere is going to be protected, and I'm not all that concerned about humans picking up a microbe and an infection. It's also true that in natural biology on Earth, parasitism is very closely tied between the host and the parasite. So you see viruses and their host co-evolving. So the idea that I can get a virus that infects, a plant to infect a human, not really. A virus that infects a Martian plant, a human, okay, I would be more than astonished. Now, I've been astonished in the past, so, but I don't think it, but I do believe that due diligence, this is Jan Spacek has basically persuaded me of this, that one really does need to do an assessment of the Martian biosphere before you put humans on Mars for a lot of reasons. That you're going to have to be doing water mining before you put humans on Mars, so that you know you can do it and make propellant before you send them on a one-way trip. And while you're doing it, since we have the agnostic life finder instrument under development and the polyelectric light theory of the gene based on lots of work in synthetic biology to support it as being a universal life detection system. And since Elon is going to be pumping metric tons of water as an astrobiological sample, that's huge, right? When we talk about NASA missions, we're talking about a milliliter of something. It seems to me that it's a no-brainer to do an agnostic life finder, set astride water mining on Mars to see if life is there before we send humans, since we're going to be doing it anyhow before we send humans.
What about the question about ethics?
Yes.
If there is a Martian biosphere,
yes,
okay, which I know is going to ruffle feathers just hearing that phrase, but then if we go and we are disrupting, maybe some people, I don't get the sense that Elon Musk cares too much about this.
I've not talked to him about this, but the bottom line is that, look, you have to agree that when Columbus came to the New World, right, he destroyed something and he made something. And we can discuss at great length what the net result of the destruction and the construction that occurred in the New World following the arrival of the Europeans. And, I suspect there will be much less of that, partly because there were already, you and your kind had already come across the Bering Strait and eaten all of the large animals. We had camels, we had mastodons, we had all sorts of things in the New World before you and your kind came across the Bering Strait and ate them. So human migration is going to destroy things and it's going to create things. And so the question is an ethical one. Do you therefore not explore?
Well, taking his point of view is that, humans, he firmly believes that humans need to become a multiplanetary species.
He does.
If you look at our planet, there's been several catastrophes that have, made most of life on Earth go extinct.
Yes,
okay. Absolutely. So humanity needs a backup planet. I get that, and I think that's a noble cause. And I think this discussion that sometimes people, they get sidetracked. Well, if we can't fix the problems here on Earth, why go to Mars? And that's not the discussion here. It is simply just ensuring the survival of our species. I get that.
Well, it depends on your time scale, right? The sun will, over time, expand to become a red giant. You are going to find Earth uninhabitable at some point in that expansion, and it will occur in 500 million years. Now, okay, so Mars makes a lot of sense, even if we're talking about the destruction of the Earth, not by an atomic war, but rather by just the natural solar evolution. So there you go. But 500 million years is, that's a little long for me, but
why not get started now? I get it.
Why not get started now? No, it's an interesting question. As well, you're already down to what is the meaning of life, right? Right. So if humans are going to go out and be if you're going to talk about that time scale, you're not just talking about interplanetary species, you're talking to be an interstellar species. And of course, for those of you who don't think we can travel faster than the speed of light, which, has to be one of the more robust physical laws at the moment, you have an obstacle. But if you're going to talk about the billion-year time scale, and it's an interesting problem to talk about, you have to be an interstellar species.
Lastly, for anyone in the scientific community who firmly believes there's absolutely no evidence whatsoever for current microbial life on Mars, how do you respond to that?
You don't go look for it. There you are. Well, when someone says to me water is H3O, I ask them, why do you say? Right? I don't say you're crazy, you're wrong. What do you think? So if someone tells me there is no evidence for life on Mars, I would take that extant life on Mars, I would take that as an introduction to a conversation, right? Now, your problem, again, is you have me seriously worried, right? In the sense that, at least in the community that I circulate in, I don't find people who are unwilling to, that's not true. I have all sorts of people I can talk to who don't want to engage in a conversation. Origins of life, every one of these fields can be, in principle, quite an argument. And you got to keep in mind that there is a scarcity of resources, and the peer review assignment of resources is going to be based on assumptions, some of which are going to be well-founded in data, some of them which are not.
How many conferences do you go to where they're talking about current life on Mars?
Well, not lately. I mean, the one that Mike Meyer at NASA headquarters put together in Carlsbad in 2019 is really the last, but I've certainly found in that room, now it's a self-selected bunch, right? So in that particular room, everybody was well aware of the potential for life on Mars.
The potential. What about the evidence for life?
But actually, no, and there's a 25-page paper that came out of this you can go read, and that paper is chock full of what the evidence is, where life might have found a way to survive, and where
they keep talking. They want to just move the goalposts. They're like, if we dig far enough in the soil, it might be down there.
Well, go read the report. The report comes up with the conclusion that we should go, and then Amy Williams has put together for the Decadal Survey, which is a much more official document than a conference report. And the only point is it's 2042, and so the problem, or somewhere in that vicinity, and that's because Amy and her team were they were told their constraints for budget.
Sure.
So we need to have Elon Musk step up and make the commitment to do this.
You're in the know. You know all this stuff. Okay, that's what makes you a good scientist. You not only know your field, you know the history of your field, and you stay current.
Yeah.
Okay, but the people communicating on Mars, on this idea of evidence for life on Mars, the people in the spotlight, aren't saying these things.
Isn't that your job?
The scientists, who have a more public profile, they aren't talking about these things. Well, so that's why when I find people like you, I'm like, well, yes, you've been in the media a little bit, but not to the extent of these other folks. And I don't
I'm not doing my job.
No, you're doing a great job. I just don't think enough people are hearing you.
Well, look, it's an interesting problem. So I did send you a copy of a book draft that I have written, which we're looking around for a publisher for now. There was a paper which was put out in 2017, John Rummel, who used to be head of planetary protection of the United States government. I think about that's a great title. You go home at night and tell your kids, hey, your dad's head of planetary protection for the United States government. And they have a piece saying that the reason why no one is advising to go to Mars is because no one thinks it. The community, is what they say, does not think it is worth doing. And I have written chapters in this book draft as to why the community thinks that and how the community might change its mind. And you're looking at this entire sequela of events that we just discussed, right? It started with Viking. It started with Percival Lowell, right? I mean, Mars was alive. Of course, then Mariner has some flybys and Mars was dead. But then, they went back and they looked at it was above the triple point of water that Mars is alive. They sent Viking. Then Mars was dead. It took until 1996 when Bill Clinton and the Allen Hill Meetings, Mars is back alive. And you're going through these cycles. But Mars right now is in a situation where the sample return, which was designed to look for past life, has had cost overruns, and we're not any longer certain that the samples will be returned. Part of the problem is Barry. He tells, we can't return the samples because we're going to kill everything on Earth. That drives that cost enormously. And as you know from your discussions with Robert Zubrin, that's a wasted amount of money and it's preventing the samples from being returned. You've got Elon Musk, force of nature, which is driving the notion, which we never had during the Apollo moon landing season, that there could be a private operation to do it at all. It had to be a government operation. Musk is basically democratizing launching. He's cutting the law. It's amazing what the guy has done.
He's a visionary.
Yes.
Yes, certainly.
And so he wants to put people on Mars. And so right now, that's the goal. And if we could get Yuri Milner or Jeff Bezos or Frank Laukin or any of these other people, that involved as well, you would be able to go to Mars and do life detection. And while I think Richard Hoover is a little bit more optimistic than I would be, I would not tell the public that we're anywhere near certain to find life on the near surface ice. If that ice were on Earth, we would find life on it.
But I just think voices like yours, I mean, you're a well-credentialed scientist, you're working today. I mean, people respect you, but still, I think your point of view related to the Viking label release and evidence for life on Mars is in the minority.
Well, yeah. So, I mean, but, so when they had this committee, right, the standards committee to decide what we should let the public hear and what we should not let the public hear, there were people on that committee who were aggressively arguing that what basically you have just argued, that we should really get to Mars before humans get there and then maybe contaminate the science. And they were thrown off the committee. So they were canceled.
Isn't there value knowing whether or not, one way or another, 100% definitive, before we go and start putting boots on the ground, which we should do eventually? I mean, wouldn't it be worthwhile to know whether or not what's going on exactly there before we go there?
You've read my blog, you're singing my song, and I'm not going to disagree with you. We should know before we go. The timeline of going is a flexible one. Musk has talked about 2028. He's not putting people on Mars in 2028. The Chinese National Space Agency is talking about 2033. You can see how, from a political perspective, that might be something that they might actually do.
Yeah.
And they might. And, it's not, forget Chinese. I have met individuals who are perfectly willing to go on a one-way trip to Mars. Yeah, there's a lot of people.
Sure.
And, the pilgrims who came to the New World in the Mayflower were on a one-way trip. They were not going to go back.
It's not even necessarily about a question about astronaut safety.
Yes.
Take that out of the discussion. Just the value in knowing about how life could develop.
Yes.
Could life have and did it develop independently?
Yeah.
Was there this contamination that happened between the planets? What relationship is that to us?
Yes.
Before we go and...
I find all of those results would be, even if we find that there has been intercourse between Earth and Mars, and so the Martian material life that we find is very fundamental very fundamentally related to Earth in some sense, but how it adapted to changing Martian environments, and of course Earth's life also had to adapt to changing Earth environments, would be an extremely important experiment or discussion in molecular biology. It would add huge dimensions to what we understand about the connection between chemistry and the phenomenon that we call life.
This is the continuing series of Blue Planet Red, an award-winning documentary film on the history, evidence for life, and catastrophes that contributed to the death of Mars. The documentary includes interviews with NASA's lead astrobiologist, university professors, aerospace industry scientists, and independent researchers. If Mars was like Earth in the distant past, could there still be life there now? What happened to it? And what turned a blue planet red?